Hi, my name is Samuel, and in this tutorial I want to talk about the basics of shaders in GODOT. There is a lot of information out there, but in my opinion it's quite complex. For example, there is the following website, GODOT Shaders. Here you can find amazing examples of shaders. However, you can notice that it's difficult to understand. There are too many things going on at the same time in the code. As a beginner, you won't understand this if you don't have the theory behind it. What you have to do is to learn step by step from the basics. And in my opinion, the primary aspect of a shader is color. What you see on your screen is the well-known side of the book of shaders. In the first chapters, it describes what a shader is, how it works. It tells you that it works on the GPU instead of the CPU. That is why it's so fast. An important point, at least for me, is that it mentions that the lines of code that you write in the shader are executed on each pixel on the screen. The shader takes a position and returns a color. So, at the end, the result of the shader is just a bunch of color pixels on a certain position, an image. You will read this introduction, it's worth it. Actually, there is a lot going on besides just returning a color, but we can simplify things if at first we think only in color. This is the RGB color space, which uses the additive color model, where the red, green, and blue colors are combined in different proportions. But what is really important is that the colors are represented as vectors. The dimensions are represented by RGB coordinates, and we can interpolate from one point to any other point. This is a key aspect, as we can mix any color and get very interesting effects. In addition to that, the blending looks amazing, as you can see. And finally, we're going to use interpolations all the time writing shaders. Below, you can see the visual representation of an interpolation using vectors. All the color points inside the cube are vectors, possible vectors, and if we have 255 values of red, it means that we have 255 possible vectors. If we multiply all these values together from the RGB dimensions, we have 16 millions of possible combinations or vectors. A vector is usually represented with an arrow pointing from the origin to the destination, but if there are too many of them, as in this example, we can represent them as points. This is just an example of the RGB color space and color interpolation. As I said before, the key aspect is that we can interpolate from one color to any other color, or in other words, we can interpolate from one vector to any other vector. The dimensions in the RGB color space are represented by the RGB primary colors. In general, we're going to use a lot of vector math to do color operations. So, vector operations like subtraction, addition, and multiplication are not going to be strange to us. This is just a diagram in Blender to illustrate how we're going to work in GODOT. To keep things simple for now, let's work with GODOT's Viewport. The viewport is something like a buffer between the 3D scene and our monitor screen. The 3D scene in GODOT is projected on this buffer. So the 3D scene is represented by these three cubes here, and the buffer is this panel, and the screen is this black box. So the The scene is projected on this viewer and we can manipulate it in different ways. What we're interested in is to modify it by using a shader. This is called post-processing. Since we are not modifying the individual objects by using shader, but rather we're modifying the pixels of the rendered output. So I am in the GODOT interface and I created a new project. Now let's see how to add a viewport in the GODOT scene to modify it later with a shader. First of all, we're going to create a row node and inside we're going to add a viewport. I create a 3D scene and inside I'm going to add a viewport container, and inside the viewport container I'm going to add a viewport. So the viewport container is used to handle the viewport, and we have to select the viewport container and modify its stretch property so it expands over the entire area. And we need also to change the layout to full rect there. Now I am going to add a camera and a geometry in the viewport. So I add a camera and I am going to add a mesh instance. I need to select the type of mesh. It's going to be just a cube, so we have something to render, and I'm going to rotate just a bit like this. And now I need to save the scene so I can run the GODOT game. Save scene, and I'm going to name it main. Okay, now I am going to press F5. So I'm going to select the scene that is mine, open, and I can see now the scene through the viewport, and now we can modify it with a shader before its content is transferred to the screen. So let's write our first shader. For that we go to the viewport container node and create a new shader material, and inside it a new shader. We have to set the shader type to canvas item, since we're going to manipulate it to the image. We declare a constant vector tree, which will be our initial color. You can choose the color that you want. After that, we declare another variable, vector 3, to store the final color. Then we use a fragment processing function. This modifies each pixel and is available in the spatial and canvas item shader types. we declare a vector tree to store the interpolation color. And then a variable to store the interpolation percentage, and we animate it using the trigonometric function sine, and inside we pass an argument, the time. Then we obtain the color using the function mix that makes a linear interpolation between two vectors. Now we assign the resulting color to the output variable. And there we have it, an interpolation of two colors. This is the trigonometric function that we are using, and I just want to explain that the absolute value is used to limit the range from 0 to 1. If we don't use apps, the value goes from -1 to 1, which is incorrect. Now we're going to save the shader that we made. And we're going to create a new one. So you have to make a new shader. And again, we choose the shader type canvas item. In this case, we create only one constant vector tree to save the target color. I'm gonna choose blue. And let's use again the fragment function. And now we're going to obtain the color from the texture of the viewport using the texture function that gets a pixel, which is a color from the UV position. To do that, we use a constant UV that returns the position of the current pixel, and we obtain a vector tree. For convenience, we can use the RGB property. It is exactly the same as getting XYZ. Now we create a variable to assign the color. We use the same variable percentage and the trigonometric function. And we assign the color of the interpolation. And we output to the color variable. There is an error. It has to be a vector tree. And there you have it. Now the interpolation goes from the current pixel of the image to a specific color in all the pixels.